Here's another example of the remainder theorem. If I want to find what the remainder is, I don't like the way this is worded. I would say something like to evaluate the remainder when you divide x plus 2 in. Okay? So if I was going to divide x plus 2 in, my k would be negative 2, because it's always x minus k. So I could compare it to x plus 2, and you can see that k is negative 2. So if I want to know what the remainder is when I divide x plus 2 into this polynomial, then what I'd do is just find f of negative 2. It's pretty simple. Just f of k, which in this case is 3 times negative 2 squared plus 8 times negative 2, I'm sorry, that was cubed. This is squared, plus 5 times negative 2 minus 7. And this gives you, the remainder should be negative 9. And just for the sake of practicing synthetic division again, I'll do the division and see if I get a remainder of negative 9. So my k, in this case, would be negative 2. I'm going to divide it into this polynomial. So I drop down the 3, multiply, add, multiply, add, multiply, and you get a remainder of negative 9. So you can see how quick synthetic division is and how useful it is. Hopefully you guys can practice this and you'll see how quick it is as well. Okay, so let's try to tie all this together then. I'm going to give you a polynomial, like for the example, this 4th degree polynomial. Okay, it's got two factors of x minus 2 and x plus 3. This does show that these are factors, but I'll probably in the future just tell you that these are factors of this. And I'm going to ask you to find the remaining factors of f of x. Okay? Now if you look at this, if this is a 4th degree polynomial, then you can kind of start to get an idea that if two of the factors are x minus 2 and x plus 3, then there must be either a quadratic. There must be either a quadratic missing right here, or there must be two more linear factors. So if there's a quadratic, then it's called an irreducible quadratic. And if there's two linear factors, then we can get those two linear factors. But basically we know that this is basically a parabola. It could have 4 real zeros, in which case if it has 4 real zeros, it's got 4 linear factors. It can be factored into 4 linear factors. If by chance that it only touches twice, like this 4th degree polynomial, then this will be an irreducible quadratic right here, where the solutions will be imaginary. Okay? So we want to find what's left over then, basically. Now there's different ways to do this. What we could do, we want to find the remaining factors of this function. We could multiply these out and to get a quadratic and then divide both sides by that quadratic. So basically what we could do is, and we'll do it this way first, even though this is the longer way, we can divide both of this by both these factors. If we do that, then what we get is what's left over right there. All right, so let's do that. I would do it like this. X minus 2, I would FOIL this out first. So it'd be x times x, which is x squared, plus 3x minus 2x minus 6. Middle terms add together to be 1x. So I'm going to divide this quadratic into this 4th degree. So I'm going to say x squared plus x minus 6 divided into 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. Okay, I'm going to go a little quicker through this. You might want to pause or rewind if I go too fast, but I'm going to do long division. So what do I multiply by x squared to get 2x to the 4th? That would be 2x to the 3rd. I'm sorry, 2x squared. 2x squared times x squared gives 2x to the 4th, plus 2x squared times x gives me 2x to the 3rd. 2x squared times negative 6 gives me negative 12x squared. When I subtract, I get, this is going to be 0. 7 minus 2 gives me 5x cubed. Negative 4x minus negative 12 gives me a positive 8x squared. Now I'm going to bring down the next term, negative 27x. And now what do I put up here to multiply by x squared to get 5x to the 3rd? That would be 5x. 5x times x squared gives me 5x to the 3rd, plus 5x times x gives me 5x squared, and then minus 30x. When I subtract, I get 3x squared plus 3x, and then I can bring down the next term, negative 18. Okay? And then what do I put up here to multiply by x squared to get 3x squared? That'd be 3. 3 times x squared is 3x squared. 3 times x is 3x. 3 times negative 6 is negative 18. When I subtract, I get no remainder. So what that means then is this quotient right here is the answer for what's left over. So my leftover factors are 2x squared plus 5x plus 3. Okay? Now, I don't know if it's an irreducible quadratic, but what I can do is try to factor it real quick. If I factor it and it factors, then it's not irreducible. So let's try 2x, x, let's try 3 and 1. Okay? That works. That multiplies to give this quadratic. So basically, the final answer for my factors, the remaining factors would be these two, 2x plus 3 and x plus 1. Okay? So this fourth degree polynomial factors completely into this right here. X minus 2 times x plus 3 times 2x plus 3 times x plus 1. So in the future, what I might do is just give you two factors or give you two zeros and ask you to factor this thing completely. Okay? So I also could have you graph it in your calculator and find some of the zeros and factor it completely. But there's different ways to do it. I want you to know how to do long division and synthetic division. So I'll do it again. I'll do the same problem again using synthetic division. It should go quicker. All right, so here's my answer. I already did it with long division, so I know I'm going to get this. So what I'm going to do is synthetic division only works with linear factors. So I'm going to divide this linear factor into this polynomial. What I'm going to get then is this. It'll be a cubic. So I'll do it one factor at a time. All right, I don't know these two factors at this point for this problem, so I'm going to leave that blank. So I'm going to divide both sides by x minus 2. Okay, what that looks like then is 2 divided into this polynomial. 2, 7, negative 4, negative 27, negative 18. Okay, I drop down the 2, multiply, add, multiply, add, multiply, add, multiply, and add, and I get 0. So this is my answer for right here. Right there must be then 2x cubed plus 11x plus 18, I'm sorry, x squared, plus 18x plus 9. So this whole thing, I divided both sides by x minus 2, and I got a cubic left over. Now I know part of that cubic is x minus 3, so what I can do now is do synthetic division again and divide this x plus 3 into this polynomial, and I'll get what's left over right here. So let's do that. We'll do synthetic division. It'll be negative 3, because it's always x minus k, in which case x plus 3, k must be negative 3. We're going to divide it into this polynomial. So 2, 11, 18, and 9. Drop down the 2, multiply, add, multiply, add, and multiply and add. And this gives me what's left over right here, which was 2x squared plus 5x plus 3. And now I'm basically done. This is the leftover, this is the remaining factors of this function. And if I want, then I can factor this again by just guess and check with the two linear factors. Okay? So you can see how synthetic division went a little quicker. But what I did with synthetics, I divided it each one individually. So first I divided the x minus 2, and I got this, what was left over, which was a cubic. And then I divided both sides by x plus 3, and it gave me this. Okay? So this is going to take some practice. We'll make another video with homework help questions, and hopefully this will make sense after some practice.